Hi, Geometry. This is Unit 3, Lesson 13, and I think I told you in Lesson 11 it was my favorite lesson of the unit, but this might be my favorite lesson of the unit. So let's take a look at this one, using the Pythagorean theorem and similarity. So first of all, this triangle, this says, is triangle ADC. ADC is this little triangle on the right, similar to triangle CDB, this triangle that's on the, this is on the left, on the right here. So let's take a look at those two little triangles. This says 53 degrees. This says 37 degrees. That's my right angle. So I know this is a right angle. Let's find out what my third angle is. So 180 minus 90 minus 30, or I'm sorry, 53, gives me 37. So this little angle is 37. And in this triangle here, if I do my 180 for my triangle minus my 90 minus my 37, I'm not shocked to get 53, which is the other angle in this triangle right here. So it looks like these two triangles, triangle ADC on the left is similar to triangle CDB on the right by angle similarity theorem. And because they give me so much information, they also give me information about my side lengths. You can also prove that these two triangles are similar by using side, angle, side, or even side, side, side. So I'd like to do that to give you another example of that. So let's also show this. Let's decide to do side, side, side. So I want to also show this using side, side, side similarity theorem. So I want to remind you that if you're going to use that on a quiz or a test, you have to show me the proportions. You have to show, the ratios. You have to show me the ratios of the sides. I don't care if you do big over little or little over big, but you have to do the same for all three sets of sides. So sometimes students, especially depending on the triangles, they're not sure what to match up. Right triangles are a little easier, but I want to remind you that in this little one on the left, this is my smallest side. This 7.2 would be the medium side, and this 9 is the longest side. That's in the little triangle. With the triangle on the right, the 7.2 now becomes the smallest side, 9.6 is my medium side, and 12 is my longest side. So when I go to put my ratios together, you're going to want to write your small over your small. Then you're going to compare your medium over your medium, and then you're going to compare your long side over your long side. Again, it doesn't really matter if you put the bigger number on top or the smaller number on top. You just want to do the same for all three of them. So let's do this one doing the smaller number on top. So 5.4 over 7.2 is what I get. For medium over medium, it's 7.2 for the little one, but then that's 9.6 in the big one. And for the long one, that's 9 in the little one and 12 in the long one. So since these are decimals, I could get a decimal answer, or I could multiply both top and bottom by 10 and reduce by 9, because it would be 54 over 72. I could do it by hand. 5.4 divided by 70, or 7.2. 5.4 divided by 7.2 gives me 3/4, 0.75. Again, if I was getting a number I was less familiar with, you could use the fraction to decimal key and it would give you the 3/4. So I can use the 0.75 if I wanted to. I could write it as 3/4 if I wanted to. It doesn't matter. But I would do the same thing for this ratio and find that I would get the same answer, whichever way I want to write it. And same thing here. I would get the same answer. What I'm trying to show is that all three sides are in proportion, meaning that they have the exact same ratio. That's how I prove the side-side-side similarity theorem. You could also do side angle side for this particular problem. So let's flip to the next page, page 402, and look at 13.2. It says trace the two smaller triangles onto separate pieces of tracing paper. That would be patty paper. Instead, what I want to do is actually draw the three triangles, not two, but the three triangles in this picture. So let's begin with this triangle right here. This is the little triangle, and the right angle is G. So I'm going to have a little triangle. I'm actually going to have a medium-sized right triangle. And finally, I'm going to have the large whole right triangle. So let's take a look at the little right triangle first. This is G. The short side goes out to H. This tall side goes up to E. And this is my hypotenuse, HE. I know it's 12. I know H was 53. So what's the medium triangle? Well, the medium triangle is the right side. This right here would be my medium-sized triangle. And my right angle is also at G. So this is G. My longer straight side goes up to F. And my short side in this triangle, G, goes to E. And I can verify it because my hypotenuse is EF. And my hypotenuse in this triangle, that's the side across from my right angle G, is EF. So the larger one is this entire triangle, this whole thing, both the triangles together. The right angle at this time is actually at E. The longer side goes up to F, and the shorter side goes over to H. So this would be H in that triangle, and this would go up to F. And my hypotenuse across from the right angle would be HF. And my hypotenuse across from my right angle E happens to be HF. So those are the three triangles in the picture. Let's fill in some information that I didn't bring along. So F in the medium triangle was 37 degrees. And the EF side was the hypotenuse in the medium triangle, and that's 16. So EF is 16, but EF is the tall side there in the bigger right triangle. HE was 12, it's the little side. HE is the little side in the big triangle. And H was 53. So this is 53 degrees. And F was 37. So I think I've transferred my information over. So I want to point out when I have a right triangle and I know two of the sides but not the third side, I can always use the Pythagorean theorem to help me find the missing side. Let's take a moment and find GF. So I could say GF is obviously the hypotenuse. It's across from the right angle. So in my Pythagorean theorem, a squared plus b squared equals c squared, I do know that my c squared is HF. So this is my hypotenuse squared. And then 16 and 12 are my A and B. It doesn't really matter. I need to have a 12 squared and I need to have a 16 squared. So this is 144 plus 16 squared. So 16 squared is 256 plus my 144. And I get 400. So HF squared. And so then I'm just going to write into the next problem. 400 equals HF squared. And when I take the square root of both sides, I get 20. I want to remind you where that is on your calculator. On this calculator, the square root is this button right here. I simply press it and I get 20. So this is the other popular version of calculator in our class. If you want to square something, the square button is right here. And so I can hit equals and it squares it. Let's say I want to take the square root. Notice the square root, don't do the cubed root, fourth root, one up above that has a little x in the index spot. This is the square root. It's above the x squared and it's light blue. So you're on this calculator, you've got to touch the square root first. It puts a square root on your calculator. And this is where you'd put the 400 and you'd hit equals and get 20. I want to also show you where I'm on this calculator, the answer button. The answer button is above the minus sign. The way you can use the answer button is if you're doing a calculation, so you've got your 20 squared, and now you want to take the square root, which is 20. But let's say you're not sure about that. You have 400 as an answer. If you do second and square root and your 400 just went away and you forget the number you had on your calculator, the answer is the last answer on your calculator. So it's above the minus key, so you have to hit the light blue key, and then you touch the minus key, and it puts answer on your calculator. If you hit enter, it's using the 400 in your calculation, so it's kind of handy. Anyways, 20 then is, or GF is 20. So it says write 3 similarity statements. So let's write 3 similarity statements here. So triangle, you can name this any way you want, in any order you would like. Let's do EGH. EGH, but now I've got to name all of them the same way. So FGE, and finally the last one would be FEH. So now it says determine the scale factor for each pair of triangles. So now I need to set up a scale factor. Well, remember what the scale factor is. The scale factor is an side of the image over a side of the original. So in this particular one, let's calculate it as the scale factor of the little to the medium one. And then we'll do a scale factor of the little to the large one. And then we'll also do a scale factor of the medium to the large. So you could pick any corresponding sides. I happen to know the hypotenuse, and the hypotenuse. And so I'm going to use the 12, the 16, and the 20. So it doesn't matter whether, so the little and the medium, it doesn't matter whether I write 12 over 16 or 16 over 12. That part doesn't matter. When you go to write a proportion, if you're using the 12 over 16, then you need to keep that in mind when you write the other side, the equal sign. You're doing little over big, for instance, or big over little. That's when you have to pay really close attention. So I'm going to write 12 over 16, which reduces by 4 to 3/4. So you could say the scale factor for little to medium is 3/4, or it could be 4/3. Both are correct. It depends on if you're doing little to medium or medium to little. The way I did it, it would be 3 over 4, but 4 over 3 is not wrong. It's also correct. So now let's do the little to the large. So that's the 12 and the 20. So I'm going to do 12 over 20 and reduce by 4 and get 3/5. So the other answer that would be correct here is 5/3. It's not wrong. It's just not the way I set mine up, but you can do large over little and it's perfectly correct. And so now medium to large. So now the 16 and the 20. So 16 over 20 reduced by 4 to 4/5. So another answer that would be correct would be 5/4. You might be thinking, well, all the scale factors are different. Yes, because they're comparing a different set of triangles. So little, medium, little, large, medium, large. It makes sense that the scale factors are all different. It's really 3 different problems. So now it wants you to find side lengths HG, GF, and HF. So let's go figure out HG first. When you do this type of problem, usually one of the triangles have both measurements you need. The other one has the missing one you're trying to find. And so the third triangle is useless. So if I want to find HG, I know the hypotenuse, I don't know HG. Looking at the third triangle, I know the hypotenuse and I know the little side. So the triangle I'm going to kind of throw out, if you will, is the one in the middle. I'm going to use these two triangles to write an equation to help me find HG. There's 6 different proportions I could write. I'm going to do 12 over HG. Those are both from the little triangle, is equal to 20 over 12. Those are the values from the big triangle. So for HG, for me, I'm just going to keep the 12 over HG. So this is the little triangle over the little triangle equals. And now from the large triangle, the corresponding side is 20 and the corresponding side is 12. And I'm going to solve that for HG. When you solve this correctly, I want you to do this on your own, but when you solve it, you should be getting HG is equal to 7.2. This is 7.2. It wants me to find GF. So GF is this long side right here. This time I'm going to use the middle triangle, which has a hypotenuse, and the side I'm trying to find, with the big triangle, which has a hypotenuse, and the side I'm trying to find. So this time I'm not really looking at the little triangle at all. So GF, I'm going to keep the 16 with the GF, so 16 over GF. These are both from the medium triangle, so it's medium over medium. And the corresponding side in the large one is 20, and the corresponding side to GF is 16. You're going to cross multiply that and solve, and you're going to find that GF, make sure you do this work so you can verify that you can get it, is 12.8. Now, there's other ways to find GF. You could use the Pythagorean theorem to find EG, and then you could have done a calculation using the little triangle. You could do a scale factor setup to find it. There's lots of ways to find it, but you should get 12.8 when you do so. And then HF, you and I already found. We found it up in number 1. HF was equal to 20, and I found that using the Pythagorean theorem. Let's move on down the page to 13.3. Let's practice drawing the 3 triangles again. So when I draw my right triangles, I just like my right angle to be on the right side for whatever reason. So you're always going to have a small one, you're always going to have a medium one, and you're always going to have a tall one, a big one, the big one. So now let's go back and label these. So my little one, my right angle is at D, and it goes up to C, and my short side is DA, and I double check that my hypotenuse is AC, and my hypotenuse is AC. I also know my hypotenuse is 5. I know this side is 4.6. I could use the Pythagorean theorem to find AD. So now let's look at my medium triangle. So my medium triangle also has the right angle at D. It goes straight up to B, and the short side is DC. And let's double check that hypotenuse. It's BC, and my hypotenuse is BC. I did that one correctly. The side DC is 4.6. Notice the 13 doesn't have anything to do with this triangle because that's the entire side AB. So if I knew AD, I could subtract it from 13 though, and I could find BD that way. So let's take a look then at the biggest triangle. So C is my right angle, and it goes up to B. The short side goes out to A. And let's verify that my hypotenuse is AB. My hypotenuse is AB. I did it correctly. And this is 13. My little side AC is 5. And so I could use the Pythagorean theorem if I wanted to calculate BC. So those would be my 3 triangles. It asked me to write the similarity statement for the 3 triangles. So you can start it however you want with whichever of the 3 you want to start it with. I'm going to start with the little one. You could put it in any order you'd like. I'm going to say ACD, but now I'm going to match the others, CBD and ABC. I'm going to match the others in the exact same way. So taking a look at the top of the next page. So I've rearranged my papers so that we can still see the triangles. It says write as many equations with proportional side lengths as you can. So that means, for example, I'm going to do my hypotenuse over hypotenuse equals little over little, or hypotenuse over little equals this hypotenuse over little. There's so many answers. The answers will definitely vary on this one, but I'd like you to pause the video and write at least 3 proportions that would be true about these 3 triangles. I'm going to write my last one with you so I can catch up and have 3 just like you do. I'm going to do, I think, hypotenuse over long side equals hypotenuse over this side. It's really the medium side, but just so you know, in trigonometry, we call this the short side, this the long side, and this is hypotenuse, which is really the longest side. So if it's confusing you when I call this the long side and not the medium side, it's just because I'm used to when we're studying trigonometry, this is long, this is short, this is hypotenuse. But anyways, so I'm going to do the long side over the medium side. So the hypotenuse there is BC, and my medium side is BD. And so in this triangle, my hypotenuse is AB, and my long side is BC. So what I wanted you to see there is sometimes, not all the time, because if I would have done hypotenuse with, I think, short side and hypotenuse with short side, what's happening now won't happen. But sometimes, it says, what do you notice about these equations? Sometimes, and I realize it's happening in all the ones I wrote, but it doesn't have to happen. Sometimes you'll see the same ratio on the diagonal. So look at yours. Did that sometimes happen in one of your 3? Sometimes the same side is on a diagonal. We're going to be using that when we learn about the geometric mean. So let's take this idea and go to a practice problem. If you could turn to practice problem number 2. This one says in a right triangle ABC, that's the biggest one, the altitude CD. So the altitude goes from a vertex perpendicular to the other side. That's what makes it the altitude. So if I wanted to calculate area, for instance, this could be a height and the 15 could be a base if I was calculating the area of this whole big triangle. So it says we also know AD is 12 and we know DB is 3. So it says what's the value of H? So first of all, there's 2 ways to calculate this. So one of the ways is to use proportions. There's lots of proportions you could write. This is where you would draw your 3 triangles, and usually one of the triangles has nothing to offer you, and 2 of the triangles can help you. So here, when I use the little triangle, I see that I have a little side 3 and my long side of H, so 3 and H, but I don't know my hypotenuse. For my medium triangle, I know that the little side is H. I know my long side is 12, but I don't know my hypotenuse. And then for the biggest triangle, the only thing I know is the hypotenuse is 15. So an example of this, if I wanted to write proportions, is that the largest triangle offers me nothing. But if I use the small and the medium triangles, I could do something with my H over 3 equals 12 over H. There's really 6 different proportions you could write. But if I wanted to set up a proportion, I could do, for instance, H over 3. That's the medium side over the short side, or what I call the long side over the short, equals then 12 over H. Notice that H again on the diagonal. Okay, I'm going to talk about that in a moment. You can cross multiply and get H squared equals 36. Take the square root of both sides, so H equals 6. So this brings up something I want to talk about separately. So this is notes, if you will, right here. The altitude, so the altitude of a right triangle is the geometric mean of the hypotenuse, of the parts of the hypotenuse. So how do we use that? Well, geometric mean has this really cool feature. So when you have a geometric mean, it's square. So in other words, the altitude square. So in this case, h squared. I don't know why that line's there. Sorry about that. So h squared, the geometric mean, is equal to the product of the parts of the hypotenuse. That would be 12 times 3. This is what the geometric mean means. The geometric mean is really the square of the product of 12 and 3. So h squared, the altitude squared, because the altitude is the geometric mean of the parts of the hypotenuse. So the h squared equals 12 times 3. And again, to solve this, I would just take the square root of, well, this is 36. So h squared equals 36. Some of you might want to do that first. And then when I take the square root of both sides, I would again get h equals 6. It's what I got above when I use similar triangles. So this is using similar triangles, and this is using a new process called geometric mean that we'll be talking about more in class.